Welcome back, everyone, to part two. So we've introduced the students on how to make shapes and getting them comfortable, following directions about what we're going to do. And very early on, students already are introduced to symmetry. They're introduced to the word halves, quarters. So those are the kinds of things we want to start unpacking. And then as they get into the older grades, grade 3, grade 4, there's lots of transformations that's happening. And as they get into Division 2, the same thing. Our current grade 7, 8 programs all have that type of transformation. So especially in grade 7. So what I'd like to do right now is just unpack a little bit about what I might do if I was starting on transformations. We're going to revisit this again in the very last segment as well. So let's just get another Geoboard. And yeah, I'm changing colors. So Geoboards do come in different colors, in case you weren't aware of that. We had a clear one in the first session. We're just going to start with this one now. So keeping in mind what I just said, that they talk about symmetry, they talk about halves. How could I use the board then to model that? So I could, if I'm starting back here again, just putting that on, but let's go to grade 1 where I'm going to go a little bit further than that and deal with symmetry. So I might say to them, can you make me a rectangle that is 1 across and 4 long? And maybe put it somewhere in the top right-hand corner. So I'm not being quite as specific. If you feel your students need a model, then I would have a slide that I would show them where I have one done. And then if they want to count the same number of places that I do, that's fine. But at least we're giving them the opportunity to just to show us what they know. So if I have this rectangle already done, let's go back to something that they were familiar with. Let's take our green elastic and let's just extend it all the way down from top to bottom. So that is, in theory, my line of symmetry. It's like my mirror. Now, when I'm doing this with students, before I would introduce this green elastic down the center, I will have done things before they even get their hands on the Geoboards, such as if you have a carpet in your classroom, I would ask them to stand on the carpet, and I would ask them to have their toes right to the edge of the carpet. And then maybe put a pencil down in front of them and say, if that pencil was a mirror, how far behind the mirror would that be? This is a deep question for kids. They think about it a long time. So then if they get stuck, we might even say, let's bring a partner in and let's put them, where do you think your partner would need to stand to be your image that you're seeing in the mirror? And then eventually what we'll do is we'll have them take a step back and we'll use the edge of the carpet as the mirror. And we might say, where should your partner be? So what we're getting at is we want their partner to be the same distance from the edge of the carpet as they are. So talking about what does a mirror do? Now, if you have a full-length mirror in the school or you have a portable one at home that you can bring in, that's even better because now we can try it out. We can see it. We can show it to them. If you have mirrors in the school, you'd want to get that out because a mirror will let them see before what's on one side is the same distance on the other side. But nonetheless, we just did it with the carpet, the floor. That worked out well. Children explained to me what they saw in a mirror. I said, well, if I stood way back and I looked in the mirror, would I be way back in the mirror in the image too? And they said, yeah, because you have to be the same. It'll look the same distance away. So they're getting the idea. They don't have the language, but that's okay. That's not where we wanted to start. So now I'm going to ask them, now that I have my little rectangle in yellow, and this is the mirror, where do you think its mirror image is going to go? Where do you think it would go if this was the mirror? And that means they're going to use another yellow. Now, if they don't, not going to say anything about it right off the bat. We're just going to let them build it. But grade 1s have very little difficulty realizing that they have to be exactly the same distance away. What we did see lots of was different colored elastics, but they had them in the right places. Now, some of them had them in the wrong places, and we could say, this is the mirror. This is you standing here. Look how far away. So we still don't count it with them, but we'll say, look how far away you are. Where do you think your image will have to be on this side? And so once we start to point those out very deliberately with individual students, then they start to retool that. But when they put a red elastic, a blue elastic, a green elastic, we'll say, is this what you got when we showed up on the screen? Or I usually just hold this up. I literally just hold this up in class because they can see through it. And they can look down and they can say, yeah, mine's exactly the same distance away, only I used a blue. So then we can talk about in a real mirror situation, if you were wearing a yellow shirt, did your shirt change to blue when you were looking in the mirror? Oh, no, it needs to be a yellow, right? So that's the prompting kinds of things that we can talk about. In grade 1, they are looking at, I'm just going to take my line of symmetry off here for a second. They are looking at halves. So if I said to them that this is half of some kind of shape, and you have the other half, what would the other half look like? So you have to build, this is half of it, and you have to build the other half. And if they need me to show them, it's like saying you have this piece of paper. What other size piece of paper do you need to make it look the same? And they say, well, it has to be the same. Okay, so what would you build for me? So they're pretty quick at doing this. So they need to build the two halves together. And so there's one, there's the, now we've got overlap and we talk about the overlap and we talk about those pieces, but we want them to understand that they've created really the same two-sized rectangles and they would be sitting side by side. If I wanted to do an activity with them, then I might take hearts and cut them in half. I might take squares and cut them in half vertically, horizontally, and then diagonally, and then have them in different colors and they run around the room and find their partner. So they're getting the idea of what that half is. Remember, they're not using 1/2. Then I might say to them, what if I took my yellow one and I made this great big square? So I'm just going to make, I'll go this way. And I'm going to ask them, is that a square? And if they say yes, I'm going to say, how do you know that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, good. So it's a square. So now the question might be, could you cut this square in half? And if so, where would it be? Now, this is a little bit tricky. So if they're going to cut it in half, and I want them to put an elastic on. So if I was going to give them a shape to start with, maybe I might want to start with a rectangle first, bring it down. The reason I can say that, I do this with paper, I don't do it with the elastics first. I might say, where would you put an elastic, or where would you draw the line? Where would you fold your paper so that it is exactly two halves? So I need to have a halfway line, which I do right here. So I could put my green elastic, and that makes this side and this side exactly the same. So there's my halves that I'm looking for. So you could do practice with that. You could do all kinds of things. But what if I gave them a square? We're jumping up here and we're making kids think a little bit. So taking your green, and they will try that out. So they'll say, well, if you put it here, that doesn't really work. If you put it there, it doesn't really, it needs to go in the middle. So they're right, it needs to go down the middle, but I don't have any pegs that I can attach it to. So then I'm just going to leave them to ponder and say, maybe with a shoulder partner, why don't you talk about what are all the other ways I could get a half? And if they need a piece of paper that's a square, let's give them a piece of paper. Try folding your paper first. See how you could get halves. So some students will already know that they could go on the diagonal. Some of them will do it before you've even given them that piece of paper. So if they do this, beautiful. They have definitely cut it in half. Then you might say to them, is that the only one that you could find? Is there anything else that you could do? And so some of them will say, nope, that's it. So others will say, yeah, you could have gone this way. So there's two ways you could have cut this in half. I could have folded my paper this way, or I could have folded it this way. And then I'd have that and have them fold it and ask them, did both of those folds still give you the same size pieces when you did that? And the answer is yes, it is. So if they're grade 2s, we could do that activity. And now I could say, what have you created when you put these two lines on there? What have you got? So now I have quarters. right? So I have a visual for a quarter. So all the different ways that we can do those kinds of conversations with students, that's the pieces that we want them to be able to see and we want them to be able to generate without sort of being told, count this many pegs. Let them sort of muck around with it for a little while on their own. They will play, if anything, they'll start playing with the elastics, and then you know they're stuck or they're bored, one or the other. But either way, they're not going to give up on the pegboard. So it's very engaging for them. So I can do that building the half or a symmetry, a symmetrical part. So where would I fold it in half? Where would I put it? If I was doing something a little bit grander, like for example, let's make another square. We'll make it 3 by 3 this time. And sometimes if the elastics, depending on the size you get, if they're too big, we just tell them to double it. It does make it a little more challenging for them. So now we're going to try a translation. And we talk early years as it being a slide. So I need to give you some information about how to slide it and where to slide it to. So all they're going to get is I have this square, it's a 3 by 3, and I'm going to say in the bottom right-hand corner. So we give them a starting point, and that helps me with, do they know their directions, first of all? Bottom right-hand corner. I would like you to take the bottom right-hand corner and move it over 5 units to the right. So this corner is going to go 1, 2, 3, 4, 5 units to the right. So if this is my corner, I say put your finger on it. How long was the bottom of your square? 3. So 1, 2, 3. So there's the bottom of my square. I'm going to bake my square and go from there. And my instructions always when we're doing these kinds of things is, if you think you have it and your neighbor doesn't, could you help them? Don't do it for them, but can you help them? So I move the bottom right-hand corner 5 over. 1, 2, 3, 4, 5. And I would have this up on the screen so I can count with them, right? So I would repeatedly do this because they're going to need a little bit of guidance to do that. Once they've done a couple, they're very, very good at it. Especially if you give them more than just a left, right, doing up, down, doing both together. So then we have conversations again. So we could ask, did the bottom left-hand corner move 5 units over? Because a lot of students will just see the space in between. They'll say no. So we'll say, put your finger on the bottom left corner and count till you get to the other bottom left corner. How many should we have moved? 1, 2, 3, 4, 5. So they understand that when you take a shape and you shift it, it's not changing the size of the shape and everything moves along. We didn't just take the corner and stretch the whole thing. So doing that kind of work, and then I could say, could you move it up 2 units? Give me a corner. So maybe this corner moves up 2 units and maybe I have one sitting inside of another one. Or give me the bottom left corner and you're moving it down. Whatever. You get the idea that that's one of the things that I can do. So I can take my line of symmetry. I could ask them to create another one of equal distance away. And my line of symmetry doesn't always have to be 1. It could be 2 away. It could be 3 away. It's just how big your pegboard is and where they put it. Or I can do this slide. So I might, if I've got some kids that are really, really good, I might say to them, especially if they're done and others are still working, I might walk around and say, all right, here's your task. I want you to take the bottom right-hand corner and move it 4 to the right and 2 down. So that makes them think a little bit, but they'll do it. 4 to the right and 2 down. That's the bottom of my right-hand corner, my bottom. So I need it to be 3 long. And then you'll have some who'll say, I think I got it, I think I got it. And you haven't even had a chance to go and walk to another child yet. And sure enough, they do, right? So you can give them another one. So just keeping them busy with multiple moves is something that's quite engaging with the students. Now we're going to get bigger and better into transformations. We're not going to do the rotations right now. I'm going to come back to this more at a grades 5, 6, 7 level so that we can do something in a little bit more grander size. Okay, so that takes us to the end of this one. And if you're willing, hopefully we'll see you in part 3. Thanks very much.